It says here, momentum is commonly used in sports. So like I said, the sports announcer this morning, Houston Texans, they've got momentum. And what are they talking about? They're saying that it's going to be that team is really on the move, right? As in, like, not only did they win this game, the next game they've won, and the next game they won, and they're moving forward, as in wins, right? They're going to playoffs, and then the next playoffs, and the next one. Okay, not that many. They might hit one, okay? But they're on the move. They're going forward. And then it says here, and it's going to be hard to stop them. An object with momentum is going to be hard to stop. It's going to need some type of blank to cause it to stop. What was it? Some type of what to cause it to stop? Force. There you go. Gonna need some type of force. I mean, don't get me wrong. If you've got an 18-wheeler that's driving down the road at, gas pedal down to all the way, it's gonna take some force. I mean, versus if you have the chair, barely, the friction of the floor, as well as when it tapped the table, caused it to stop. It didn't need as much force. It says here that the bigger something is, the more momentum it has. Again, that 18-wheeler versus the chair moving. Or the faster something is. What is something that could be really small, weigh just a small amount of mass, but its velocity is so fast it can do a lot of damage? Bullet. There you go, bullet. Small little bitty mass, but it's moving so fast, it also has more momentum. Yep, a bullet. So can a baseball have just as much momentum as a giant boulder? Absolutely, yes. I mean, bullets can have some pretty damaging, repercussions because of its momentum, not due to its size, but due to its velocity or speed. Momentum has an equation. Don't worry, it's on the formula chart, so we don't have to memorize it. I'll just show you real quick. Here it is, momentum. So momentum is mass times velocity. That's what it said in the reading. It says it's the product of its mass and its velocity. But momentum has a really weird variable. Instead of it being like, let's say, a capital M, it's actually a lowercase p. Why? I don't know, nor do I ask. It's a lowercase p for momentum. M is mass, V is velocity, and you also know mass must be in kilograms before you do any math. Velocity should be in meters per second, but it doesn't have to. If it's in miles per hour, okay. But these two variables right here are being multiplied. There they are. They don't cancel each other out. So we keep all of the variables, and it actually comes out to kilograms times meters per second for momentum. Alrighty. So just a couple of practice problems. It says here, we've got a person that's riding a bike rider, I don't know, some kind of bike, and they're both traveling the same velocity of 45 kilometers per hour, but this one has more mass, so it's going to have more momentum. Or you could have multiplied it and just see who has the bigger number. The next one says I've got a ball that has a velocity of 30 meters per second and a momentum, lowercase p, of 15. What's the ball's mass? So algebraically, the equation is P equals M times V, or 15 equals M times 30 hopefully you can recognize to cancel this side by 30, cancel that side, and you end up with a mass of 0.5 kilograms. All right, easy cheesy, not difficult. Remember, we always like baby step it before we get into another difficult level. It says here, Grant plays baseball. He has a baseball that has a mass of 5 kilograms. Good Lord. That's like a 2.5-pound baseball. Insane. Oh, hello. Have a good day. It's a crazy baseball size, 2.5 pounds. It says here that he throws the baseball with a velocity of 22 meters per second. What is the ball's momentum? So for this situation, they gave me the mass, they gave me the velocity. My question mark is P. P equals M times V, or 5 times 22 equals blank kilograms times meters per second. Don't forget, I will rip your grade down every time we're missing those SI units. So this is a new SI unit for us. Kilograms times meters per second. Okay, now with this first page done, this covers homework number 2. So if you don't do homework 1 and 2 by this weekend, that's on you. All right? All right, let's turn the next page, because the next page is going to cover homework number 3. Like, we're rolling through this. All right? These are some pretty easy, cheesy ones for you to do. Each problem that you leave blank is going to be minus 1 point off the notes, right? All right, so let's talk about this word, impulse. Now, this word doesn't mean like, oh my God, I was shopping through Temu and I had an impulse to buy something. Not like that, okay? I was shopping at Walmart and the impulse came through me. I just had to buy it. Not like that, okay? So let's go back. Momentum. We have the Houston Texans. They're winning. They got momentum. We've got an 18-wheeler. It's driving. It's moving. It's got momentum. Well, we just talked about if you want to stop that object, you have to apply a force. Now, stopping the object that's moving would be the opposite of momentum. That's this, impulse. Impulse is the opposite of momentum. It says here the definition for impulse is a change in momentum. A change in momentum. So if I'm going to change the object's momentum, I'm going to calculate the impulse. It says here, though, with inertia, you know that an object in motion will stay in motion, which means its momentum will remain the same. Oh, yeah, that's what Isaac Newton came up with. An object in motion stays in motion. That means its momentum is going to stay the same. The problem is we live here on Earth and we have a lot of air, wind resistance, we have a lot of friction, and because of that, we have something that's opposing momentum or something that's the opposite, and we call that impulse. It says here, though, in order to change the momentum, or the motion of that object, you must apply a force. Now, that 18-wheeler needs a bigger force to cause it to come to a slowdown versus this little rolling chair, less force to cause it to come to a slowdown. But it's not just about the force. Impulse is the change in the momentum of the force and the amount of time it takes. You probably took like a driver's ed class and it says like, if you're driving a bigger, heavier car or like an 18-wheeler, they need more time to come to a complete stop than a smaller car, which is true. What they were trying to talk about was the impulse of it, okay? So not only, again, does it need to have a force to cause it to slow down, there's a certain amount of time to get it to come to a complete stop. Now, that's only if the impulse equals the momentum. It says here, though, to stop an object that has momentum, yes, it is necessary to apply a force against the motion, but you must apply the force for a certain amount of time. The more momentum an object has, the harder it is for it to come to a stop. Thus, you're going to need a greater amount of force or a longer amount of time to make it come to a stop, which is what the driver's ed was trying to explain. Hey, you have an 18-wheeler. You need to give them a lot of braking space. Why? Because they need more time to come to a stop because they have such a big mass. And we call that impulse. Impulse is the opposite of momentum. The equation for impulse, which is also on the formula chart, no need to memorize it, is going to be force, because we need to have force, times the amount of time it took to get this object to come to a stop. The variable for impulse is a capital J. Why? I don't know. I just accept it. So F stands for force, which is last semester variable. We can't, newtons. Got to remember this. T stands for time, which is a second. And J is the impulse, which is, ooh, this is weird. Okay, I'm going to pause for a moment. Well, Miss Munson, that's a newton and that's time. They don't cancel each other out. So will we keep a newton and a second? Well, that would be the easy thing. But in physics, we like equations. Now, if momentum is the moving of an object and impulse is the stopping of it or the opposite of it, then in this situation, what we like to do in physics, which will be on the next page until Thursday or something later on, we actually set these equations equal to each other. When we set them equal to each other, well, we need them to have equal amount or equal SI units. And because of that, we have the SI unit for impulse to also be a kilogram times meters per second. I know it's a little weird, but I just wanted to toss that out there. Why? Because it's the opposite of momentum. It says here, how does impulse relate to momentum? Well, impulse is a force acting for a given amount of time, which will cause a change in momentum. Right? Now, the change, though, I want to make sure that we're all on board with this. If you were standing in front of this rolling chair and I rolled it to you, right, you can stop it. If you were standing in front of an 18-wheeler rolling down at you, you probably can't stop it. Okay? What if it was a small baby car? Could you stop the small baby car? you can't stop a small little baby car, which could be, give me an example, a Mini Coupe, you can maybe do what then? You can't cause it to stop. What if 2 or 3 of y'all are in front of it?
Slow it down.
Thank you. Thank you. You can at least slow it down. So impulse, it's either number 1, it's equal to, completely equal to, or greater than the momentum, it's going to cause it to stop. If impulse is less than the momentum, it can cause it to slow it down. Okay, so it says here a football player, offense and defensive players. Well, I mean, isn't their job to slow them down? Give it to me.
Wouldn't friction be a form of impulse?
Yes, because that is the force, frictional force. Yes, yes, absolutely. So for football, right, their purpose on those front lines is to slow down those players to getting on the other side or coming through. It says here in football, the defensive player or offenses, I don't know, I'm not a football player. It says here, their job is to apply a force. But do they always slow down those players from coming through? No, not always. Sometimes they're not strong enough to stop them, but at least maybe they can slow them down. It says here for a given amount of time. Why? The quarterback needs a little bit of time so he can figure out where he's going to throw the ball, right? You need your players to either, number 1, stop them, or number 2, slow them down for a certain amount of time so I can decide where I'm going to throw the ball. Does that make sense? It says here for a certain amount of time to hopefully stop their momentum or slow it down. Here's another example. You have been in the car. Haven't you been in the car when somebody tries to brake check you? How much time did it take for them to hit those brakes? Instant. But what if they hit on the brakes slowly and easily? That was an easy slowdown. Have you ever been, I don't know, not me personally, but have you ever watched somebody get hit on the football field? I mean, they can make a choice to slowly grab them and just, hey, or they're going to come to a hard hit. And what happens when they hit hard? It hurts. It's either going to hurt them, it's going to, heaven forbid, do some major damage, concussion. Does that make sense on why they have been changing these football helmets or baseball helmets, right? Because we want to increase the amount of time that it takes for it to slow down. Alrighty, so it says here, when you're driving, you've experienced this. You're going to bring your car to a stop when you approach a stop sign. It says your brakes are going to apply the force to your car, right? We're not going to Flintstone this with your feet. Your brakes are going to. And they are going to apply this force for a certain amount of time. Hopefully enough time to change the car's momentum so you don't get brake checked. If they do it fast, you're going to brake check you. You do it slowly, it's going to be a nice slowdown. It says here, an object with momentum can be stopped if a force is applied against it for a certain amount of time is at least equal. If it's an equal amount of force, it could stop it. If it's greater, it can stop it. But if you don't have enough power to be equal, then all you can do is slow it down. Okay? And then we've got practice problems, which is going to be homework number 3. It says over here, a car is moving at a constant speed and the brakes are applied with a force of 20 newtons, and it took 5 seconds for this to occur. What is the J? Impulse. Impulse equals force times time. There you go. Or 20 times 5, which equals 100. Again, that's a weird SI unit. Kilograms times meters per second. Okay? Next time we touch notes again, we're going to actually equal these two equations to each other. So now you will have 4 variables instead of just the 3. Okay? Other than that, that is what